exam 8, and today we will be discussing geometric series, the sum of geometric sequence. Okay, so let's first discuss what is a geometric series. So the same as arithmetic series, we are going to define this as the sum of all terms of the geometric sequence. So there are two formulas under this. This is the sum of definite geometric sequence, that is S sub n is equal to a sub 1 times 1 minus r raised to n over 1 minus r, wherein our n here pertains to the number of terms that will be added. Next is the sum of the infinite geometric sequence. The formula will be S is equal to a sub 1 over 1 minus r. Okay, to better understand what are these formulas are for, so let's have our examples. Okay, for the first example, under the sum of finite geometric sequence, we have find the sum of the first 8 terms of the geometric sequence for 8, 16, and 32. We'll be using the formula S sub n is equal to a sub 1 times 1 minus r raised to n all over 1 minus r. Okay, so in the sum of the finite geometric sequence, we're talking here about exact number of terms that will be added in the geometric sequence. So here in our first problem, we're going to add 8 terms of the given geometric sequence. So from 4 up to its 8th term. So instead of determining the other terms until the 8th term, then adding it, we will use this formula. Okay, to do that, so let's solve this. So first, of course, we will write first our given for our first problem. And that will be our a sub 1, which is equal to 4. Sorry for that. Then we have our n is equal to 8. Our ratio, which is equivalent to 8 divide 4 is 2, 16 divide 8 is 2, 32 divide 16 is 2. So therefore, our common ratio is 2. Okay, since we are okay with our given values, let's now substitute our given formula. So that will be S sub 8 is equal to a sub 1, which is 4, times 1 minus our ratio, which is 2, raised to 8, all over, 1 minus 2. So substituting or evaluating first our exponent. So let's copy 4 times 1 minus 2 raised to 8 is equal to 256. Okay, so that means we are going to multiply 2 8 times. So we will arrive with 256 all over 1 minus 2. So 1 minus 2 is negative 1. So that is equivalent to 4 times 1 minus 256 will be negative 255 over negative 1. Multiplying this, so you will arrive with negative 1024 divided by the negative 1. So we cancel this. That is equivalent to 1,204. So this will be the sum of the first 8 terms of the given geometric sequence. Okay, so let's have the next one. Okay, for our next example, find the sum of the first 5 terms of the given geometric sequence 1, -4, 16, and -64. So as you can see, our geometric sequence here is in alternating signs. So from positive to negative, negative to positive, and so on. So just like what I have said when we discuss about geometric sequence, when we have alternating signs on the geometric sequence, it means that our ratio will be a negative number. Okay, so let's write first our given. So our a sub 1, excuse me, sorry, let's go back. Okay, so for our a sub 1, we have here 1. Then for our n, we have 5. For our ratio, the ratio will be -4 divide 1 is -4, 16 divide -4, that's right, -4 divide 1 is equal to -4. And let's see, 16 divide -4 will arrive with -4 also. So our ratio will be -4, which is a negative number. Okay, next, let's write the formula. So that will be S sub n is equal to A sub 1 times 1 minus R raised to n all over 1 minus R. After writing the given the formula, we will replace or we will substitute all the given values that we have. So A sub 1 will be 1 times 1 minus the common ratio, which is -4. So let's put that inside the parenthesis, raised to 5. Okay, all over 1 minus the -4. Okay, so that will be, let's perform first those that are inside the parenthesis. So copy 1 times 1 minus, what will be -4 raised to 5? -4 raised to 5 means we will be multiplying -4 to itself 5 times. And that is equivalent to -1024 all over. Okay, here we have 1 minus the -4. So that means we will have 1 plus 4. So next, that is equivalent to 1 times 1. Since we have their negative times negative, we will have positive plus 1024 all over 4 plus 1, or 1 plus 4 is 5. Next, perform. 1024 plus 1 will be 1 times 1025. There. All over 5. So multiplying 1 with 1025, that is equal to 1025 over 5. 1025 over 5 is equal to 205. Therefore, the sum of the first 5 terms of the given geometric sequence is 205. Okay, is that clear? Okay, so let's proceed now with the next one. Okay, now we'll be discussing about the sum of the infinite geometric sequence. So when we say infinite Walang katapsan. Ano po? So on and so on. Okay? As long as there will be a number. Okay, so let's see. Pwede bang makuha ang sum ng infinite geometric sequence? Oo, pwede. Kaya lang, meron siyang restriction or merong dapat sundin. Okay? So let's see. Find the sum of the given geometric sequence 2, 6, 18, and 54. Okay, so do you think we can find the sum of this particular geometric sequence? Okay, so after 54, so this will be times 3, times 3, times 3, times 3, times 3, times 3. So as you can see, after 54, we'll be multiplying another 3, so that will be a bigger number. So as you can see, the geometric sequence here is in increasing order. So we call this geometric sequence as divergent sequence. Again, divergent. Divergent means that the given sequence got bigger and bigger in the value wherein it goes far from 0. In that case, we cannot determine the geometric sequence of, or the sum of the geometric sequence in this case. Okay, wherein the R or the common ratio is not equal to 1 or the common ratio is greater than 1. Mas malaki sa 1. Okay? Let's have the next one. I have another example. Okay, find the sum of the geometric sequence 8, 4, 2, 1, 1/2, and 1/4, and so on. Is it possible to find the sum of this kind of geometric sequence? Yes, it is. This is what we code as convergent sequence. Excuse me. Okay, this is called as convergent sequence. Convergent. So, kabaliktaran ni divergent, ang convergent sequence, ang ibig sabihin nun, the values of the given geometric sequence is going nearer, smaller and nearer to 0, wherein we can come up the sum of that particular geometric sequence. So, to find the sum of the infinite geometric sequence in this case, wherein R, or the absolute value of R, is less than 1. Okay, so to find that, we'll be using this formula. S equals A sub 1 over 1 minus R. So how is that? Excuse me. So let's look first with our first term. A sub 1 is 8, and our ratio will be 4 divide 8, 4 divide 8, that is equal to 1/2, which is less than 1. Am I correct? Or is less than 1. So we have 1/2 as our ratio, common ratio. So using the formula, we have sum is equal to A sub 1, which is 8, all over 1 minus 1/2. So that is equivalent to 8. All over 1 minus 1/2 will be 1/2, because 1 will be equivalent to 2 over 2. 2 over 2 minus 1/2 will be 1/2. Simplifying this, that will be equivalent to 8 times 2 over 1, reciprocal. So we will have 16. Therefore, 16 is the sum of our geometric sequence. Okay, so again, we can only find the sum of the infinite geometric sequence if it is a convergent sequence. And what is a convergent sequence? Convergent sequence or geometric sequence wherein the values of the terms are in decreasing order. The terms are getting smaller and smaller and smaller until it reaches approximately 2, 0. we can find the geometric or the sum of the geometric sequence of that particular terms. Okay? So I hope you understand our discussion today, and I hope you tune or you follow